I'm Nelson Petrojek, CTO at TIBCO Software. TIBCO is really focused on the integration and analytics space. And so this topic tonight is very, very relevant to us and obviously to all of you. I'm very excited about this, talking about industrial IoT, the evolution of IoT, and some of the new future trends that are going on in IoT is very, very exciting. And I think this is going to be a very, very good talk tonight. We were having a conversation previously around some of these topics, and we were able to blend in everything from AI, ML, edge computing, cloud computing, cognitive sensing, and we wrap that all into about a 10-minute conversation. So we'll get to drill down on it a little bit more in this particular session. So first, I'm going to turn things over to the Hive. They're one of the sponsors, of course, for tonight's event. And so Katie is Director of Marketing at the Hive. I'll turn things over to her, and we'll take it from there. So thanks, everybody, for coming out. Enjoy the rest of the evening.
Thank you, Nelson, and thank you, TIBCO, for hosting the event tonight. We're really excited that you guys could all come out here and join us. So just real quick, I'm Katie Frisch. I'm the new marketing director at the Hive. I come from Intel Nirvana. So Nirvana was acquired by Intel in 2016. And I was recently part of Google X and the self-driving car. And then also I have a huge passion in athletics and went to Olympic trials for swimming. But enough about me. So the real reason why you're here is the Hive think tank. So we've created an AI ecosystem. It's an event platform. It connects all of you guys together. And we've hosted over 185 events. There's 10,000 people that are part of our community. And we recently just launched the Medium platform, which is now a virtual community. So now you can go to the Hive on the Medium and learn about all things AI. It's your resource. It's something that we're going to be publishing a lot of content, and it's something that you should definitely check out. So some of the things that we're going to be talking about in the Hive think tanks is definitely we have a focus on AI, but then also health, blockchain, financial services, Internet of Things, entrepreneurship. It's your resource. It's what you guys should be going to. And then we couldn't have done this without entrepreneurs, without thought leaders, without corporations. And a lot of these people we actually have and will host their content on the Hive Medium platform, and then also our sponsors. And so if you are interested in participating, you want to contribute to our Medium platform, please reach out to us at marketing@hivedata.com. And then definitely just check out our site. And then I will turn it over to Ravi, who's the managing director of the Hive. Thanks, Ravi.
Thank you, Katie, and welcome, Katie. And I want to thank Matty and Erin. Where's Erin? Erin. Erin is just an awesome force of nature who makes this all happen here at TIBCO. So we are a studio, a co-creation studio, and a fund that is focused on AI-powered companies. And today we were in the news because we sold a company called E8 Security to VMware. And so that's sort of our business. We are very focused on a set of themes, and you'll see sort of smart machines, which is a euphemism for industrial IoT, a set of industries, including the industrial segment. And we don't do kind of horizontal technology, but typically applications and use cases of ML and deep learning, chatbot kind of use cases, edge intelligence, and so on. So that's sort of a bird's eye view of how we think about investing. We have been in the industrial space for some time, and I'm very pleased to kind of have our speaker here today, because one of our more successful companies, Foghorn, Sujit, was very early sort of mentor to us. And I remember a use case around pump cavitation, which we were able to show at Cisco IoT World Forum, that he really gave us guidance on what to do. So we have a whole set of companies. Nurego was acquired by GE. Sage Security is providing edge security. And we have two companies that come from the Hive India. So we have a point of view in different areas. You know, I talked about the different themes and in different industries. So for each of them, we have a point of view. I won't go through all of that, but in the enterprise where we play very broadly, we think about the journey to the autonomous enterprise and how we're going to get there. So a lot of our focus is around use of kind of AI approaches for process optimization, process automation, replacing sort of in sales, support, service, where you have people engaging with people, getting kind of assistance, augmentation, and for some of the tasks, automation. And generally think of the cognitive enterprise apps as any app that you have today in your enterprise that was built before sort of the days of first-party, third-party public data, big data, ML, and deep learning. Those applications are not taking advantage of data. So that's kind of broadly what we think about. I would encourage you to tweet today using kind of use the hashtag HiveData. That's our Twitter handle. With that, I'd like to introduce Sujit Chand. Sujit is the CTO and SVP of Rockwell Automation, and he's going to talk today about digital twins. If you can please hold your questions to later, and we'll have ample time for Q&A. Sujit.
So, Ravi, thank you very much. I'm going to switch computers here for a second. Thanks. I'll just plug this in. Yeah. Okay. Well, I want to thank TIBCO and the Hive for the opportunity to speak here this evening. And thanks to all of you for spending the evening here and listening to the discussion today. I have a good friend who is a serial entrepreneur, and he lives in the Valley. And I told him that I'm giving a talk, and I said, what do people expect in Silicon Valley when you give a talk? He said he goes to a lot of talks, and what he looks for is 1 or 2 insights that he did not have. So my goal today is to give you 1 or 2 insights that you do not have. So that's one of my goals. Second, I know most of you are engineers, so I'll be very precise about what I'm going to cover. First, I'm going to talk a little bit about what is going on in this whole space of digitization, whether you call it digitization in manufacturing. Sometimes it's referred to as Industry 4.0, smart manufacturing. At Rockwell, we call it connected enterprise. They pretty much mean the same thing. We'll talk a little bit about that. And then, of course, the most important topic, digital twins. Digital twins, it's like the 3 blind men feeling the elephant. And each one has a different definition of the digital twin, but we'll try to get to one definition. And along the way, as I progress through the talk, I'm going to make some provocative statements. I want you to challenge those statements. I want you to think about those. So that's my goal today. I'm going to try to keep you awake by making some provocative statements, by giving you some insights that I did not dream up by putting my feet up on my desk and thinking about it. But about 1/3 of my time I spend with our customer base. And Rockwell, I'm going to talk about Rockwell in a second, but we work with a lot of different industry verticals. And a lot of these industry verticals are on the same journey of digitizing. And some are ahead, some are behind. So some of the insights that we gather from working with customers, I'll share that with you. And again, feel free to ask questions. As Ravi said, I'll run through my talk in about 35, 40 minutes, and we'll have ample time for questions. So with that intro, let's dive right in. So it's a quick introduction to Rockwell Automation. This talk is not about Rockwell. I'm not going to be talking about what we're doing at Rockwell or how Rockwell is building products or services or software for digitization. This is the only slide on Rockwell. So Rockwell Automation is a company that's solely focused on industrial automation and information. This is all we do. This is our main focus. We're about a $6.5 billion company, 22,000 employees. We're a global company. We're 114 years old, kind of unusual for Silicon Valley. So, and we survive for this long because innovation is one of our core values. We are constantly innovating and trying to change the game. And that's the way you survive and reach 114 years. Well, what we're most proud of, we are a Midwest company. We're very proud of being one of the world's most ethical companies. This is the 10th year in a row we were recognized as one of the most ethical companies in the world. That's something we're very proud of. So with that quick intro to Rockwell Automation, let's talk about digital transformation. This is a survey that was done last year by Microsoft. They asked a whole bunch of companies, what are they trying to do with digital transformation? What do the companies want from data? Obviously, we all know that everybody has a lot of data. What do companies want to do with the data? So roughly 60% said they want to use the data for predictive analytics. Make sense? Another 60%, 58% said they want to expand data storage. Bad news. You don't want to do that. And we'll talk about why. These companies that also want to expand data storage, they also want to analyze unstructured data. Again, bad news. You don't want to do that. We'll talk about why in a couple of minutes. So when we talk about digitization, when we talk about Industry 4.0 or smart manufacturing, for about a decade, we've been talking about the connected enterprise. The connected enterprise is pretty simple in terms of what it means. When we talk about connected enterprise, we're talking about two different worlds merging. The OT side, which is really the manufacturing side, operational technology side, coming together with the IT side, which we all are very familiar with. Two different worlds. The IT side tends to be very transactional. The OT side tends to be very much focused on real time. It's like oil and water. They never mixed in the past. I would go to customer meetings where IT sat on one side, OT sat on the other. They never sat together. But that's changing now. They are forced to work together because the value of taking data from the OT side, mashing it up, working with the data from the IT side, from the rest of your enterprise. Think about the supply chain. Think about the customer side. If you collect the data on customer demand, you have your supplier data, you analyze that data together with your manufacturing data, the insights you get could be very significant. You can produce to demand, you can reduce your inventories, you can basically change how you do manufacturing. So it's that promise that most of our customers are after, right? So that's what the whole connected enterprise is all about. So one of the key ideas here in this chart is that box up on top that says application expertise. So in the industrial space, unlike in IT space, the industrial space tends to be highly diverse in terms of equipment, in terms of assets that are used. What does that mean? Let me just give you an example. Let's say you go to a diaper factory in one location. You go to another diaper factory in a different location that's owned by a different company. The machines are going to be very different. Processes are going to be very different. There's a lot of bespoke machinery in the industrial space. So the application knowledge, how do these machines work? How do the processes work? That's what we call the domain knowledge or application expertise. Absolutely critical to analytics. And we'll talk about why in a couple of minutes. There's one school of thought that says, hey, get rid of that application expertise. Give me all the raw data. I'll run magic in the cloud and give you insights. Well, guess what? It's not working. So again, we'll talk about that. This is the chart where I'm going to spend a little bit of time. Here are some insights from our customer base. On the left-hand side, list any technology, any of your favorite technologies. Today there's so much technology evolution going on. You can think about the cloud, you can think about machine learning, you can think about analytics, AI, you name it. You can list a whole bunch of technology trends on the left-hand side. On the right-hand side is what's happening with these technology trends. What are the insights on how these technology trends are manifesting in use in the industrial companies we work with. So first insight, seems pretty obvious, doesn't it? Digitization is all about business outcomes. Well, most companies don't think that way. A lot of companies are focused on how do I take a lot of data from my oil wells? What infrastructure do I put in place to securely move this data? How do I keep this data secure? How do I dump it and store it in the cloud? What cloud infrastructure do I use? Do I go with Microsoft Azure, Google, Amazon? And then what analytics do I run? They're just enamored with that. They're spending enormous amounts of time thinking through that. That's backwards. What we need to start out with is, what are the business outcomes you want? What are the main pain points that you're dealing with? So let's say that your factory is significantly suffering with downtime. So if you have a food and beverage type of a factory, the uptime is around 65%. 35% of the time, the factory is down. It's being washed down. There's a lot of processes that take place. When you shut down the factory for a wash down cycle and you bring it back up, it takes a while for the system to start running again, right? So there are all these issues that companies deal with. If you identify your top business problems, then figure out, okay, if I have this question that I'm asking, how do I increase the uptime of my factory? What analytics do I need? Based on what analytics do I need, what data needs to feed those analytics? That's the right way to think about analytics. Start with business outcomes, figure out what drives those business outcomes, and then figure out what data feeds it, not the other way around. Right now, a lot of thinking is collect all data, dump it into the cloud. We'll figure out later. So one example comes from the oil and gas sector. The oil and gas sector has been collecting data. They're data hoarders, right? They collect every bit they can find. One of the oil and gas companies recently told me proudly that they have 26 petabytes of data, with a P. Petabytes. They're writing big checks to some IT companies for storing the data. It's not cheap, it's not free. Petabytes cost you a lot of money to store. Then the question is, what are you doing with it? Well, they hired a dozen data scientists from top schools. These data scientists, for the last 2 years, have been working as, in their terms, data janitors. I never heard that before. So what does that mean? They're cleaning up the data. This is all unstructured data, raw data, which cannot be fed into analytics. So a lot of these data scientists are working as data janitors, cleaning up the data. So again, going back to not adding more storage, not collecting more structured data, but focusing on what business outcomes do I want, what analytics am I going to run, and what data is going to drive it. That's going to change the game. So I'm going to stand up here and make a provocative statement. I'm going to say in 5 years, we will not be talking about big data. We'll be talking more about structured data that drives business outcomes. Okay. When I said this at a conference recently, a couple of people from a big IT company jumped at me. They said, which planet are you coming from? It's going to be all about big data. So we can talk about that later. Another insight, is all data goes north into the cloud, right? We talked about that. But when you look at how manufacturing systems are being built, most machines have significant amount of processing on the machine, right? If you look at Rockwell's controllers, today we have our controllers with quad-core processors. We have Windows 10 running in the same box as the control system. We have servers sitting right next to the box that can do a fair amount of processing. Then why would you want to take every bit and process it in the cloud? You can do a lot of processing in a scalable manner. Again, if you're in the plant, if you're in the manufacturing environment, you can pre-structure the data. You can pre-analyze the data. We did a project for a very large medical devices company recently. On one of their lines, they're collecting about 2 million pieces of data. Only 1,500 of those data elements are useful for analytics, right? So if you structure the data based on the analytics, you reduce the amount of data significantly. Now, there is a school of thought that says you don't want to do that because You don't know what you don't know. You can't discover that if you don't collect all the data. Well, the insight that I provide for that type of an argument is, for stochastic systems that are totally random, like predicting what causes cancer, predicting the weather tomorrow, you could be wrong every time and still have a job. For those types of systems, big data makes sense because we don't know the correlations, right? But for man-made systems, machines that follow the laws of physics, you pretty much know what causes what. And collecting data that's unnecessary or uncorrelated doesn't make any sense. Like one university recently did data analytics with a lot of big data they collected. They wanted to correlate the number of computer science graduates to what causes it. They found the best correlation to the number of cupcakes that are consumed in the United States. Doesn't even make sense. What are you going to do with that insight, right? So that's the whole thing about big data. You got to find out what business outcome drives it. And if you're dealing with man-made systems, like in manufacturing systems, you know the correlations. You figure out, you pre-structure the data, and you collect that data and drive analytics. Seems pretty obvious, but that's not how it's evolving. Security is absolutely key. There's no customer that I go to these days who doesn't talk about security. So security, because of IT, OT integration, is a primary topic. Today, I'm not going to get into security at all, but I just wanted to highlight it. So this is my provocative slide. I said a few things which some of you probably are thinking, I don't agree with that. We can talk about that in the Q&A session. So when you think about IoT or the connected enterprise, it's not just sensors and cloud that make up an IoT system. An IoT system starts at the core with an intelligent asset. By the way, we affectionately call this the protractor chart. So the intelligent assets are at the core, and kind of going counterclockwise from the right-hand side, you need a secure network infrastructure where all of your assets are connected. You need integrated control and information where you collect both control data as well as information. In the past, controllers that we design and any controllers that are out there that are designed by our competitors, they're very good at closing loops, PID loops, digital loops. They're really good at that. But if you give the controller energy information, say, hey, I just consumed 11 watts of energy. The controller goes, great, but I don't know what to do with it. Or if you tell the controller, I think I'm going into an overload situation. This drive is going to fail in the next 2 hours. Controller goes, sorry, I don't know what to do with it, because it's not used to processing information. So when Rockwell decided to redo our controllers, we decided to integrate information processing along with closed loop control. That's what integrated control and information means. You got to leverage the scalable computing that's available in the architecture. And we'll talk a little bit more about that. Obviously, information management, data orchestration, absolutely key. Analytics, we'll talk about analytics as well. And then mobility and visualization. So this is kind of the foundation. And with this foundation, now I'm going to get into the subject of today, which is digital twins. And this is a really important chart to talk about digital twins. So if you look at this chart, on the x-axis, on the top of this chart, what we've shown here are 4 different types of diagnostics. Descriptive diagnostics, that are analytics that produce diagnostic information, predictive information, or prescriptive information. On the y-axis, we have device level, system level, and enterprise level. Let's talk through this for a minute. If the question you're asking is, I have a pump, and the question you're asking is the pump running okay? What do you need to say that? What do you need to tell the operator that the pump is running okay? Every pump has operating characteristics. You have curves for pressure, for flow rate, and the pump operation, right? So all of these curves, you have them available. That's all I pretty much need. Am I within the operating range of my pump? And if you have that data, if you have the pump curves, you can answer this question, am I running okay? Let's say you ask another question. Is line 1 running okay? You need different data for that. You need to know the line throughput, what kind of quality you're getting, whether the line is down, what's the uptime and so forth. That's a different set of data that you need for if you ask the question, is the line running okay? Now let's say you go and ask another question. You say, which plant is performing the best? You have, let's say, 20 plants, and you want to know which plant is working the best, right? If you ask that question, the data that feeds that question to answer that question is different from the data that answers that question, right? So the insight here is, based on the question you're asking, the digital model, the digital twin, is different. So there's no one digital twin that's going to answer all these questions. So on this chart, we have 12 cells, 4 by 3. For each cell, there's a different type of a digital model that answers that question. Okay, so that's an important insight. And let's then now talk about what digital twin really means.
I have a question, if you don't mind.
Please, go ahead.
I'll throw the whole question at the end, Ravi, or is it okay to ask?
I'm good with asking questions as we go along. That's fine.
I'm just curious, when you add, I appreciate it's 4 columns, but if you added another column that's cognitive, and if you ask the question around distributed manufacturing assets, where any number of plants could be determining which plant should win the order, where would we do that? Where would we say if manufacturing as a platform emerges as a future?
Yeah.
Who would make the decision around where to send the order? Because fashion, for example, is being made in very small runs now. Mm-hmm. It's no longer this. Let's get the inventory. Let's schedule the run. Let's run optimally. It's more about real-time manufacturing. So
correct.
I'm wondering, is that included in this? Or
well, so you're asking the question. Let's say I have a dozen manufacturing plants. You get an order, and you want to know which manufacturing plant to use for producing that order. Okay, and the data that's going to drive that is proximity to who wants the order, right? And it's going to drive, what's going to drive it is which plant has the capacity and the supply chain availability to produce what you want. So the data requirements are clear, and the analytics that you're collecting would be along the plant, which plant is performing the best, right? So you would know which plants are running at what capacity. Obviously, this grid doesn't cover every question or every type of analytics you want to run. This grid is primarily focused on the different faults you might get in a manufacturing line. So your question is at a much higher level as to how do I allocate my distributed assets based on incoming orders. So that will have its own digital twin or a model to drive it, right? So it kind of supports what I'm trying to say here, but I'm not claiming that this grid is all-encompassing. But thanks for the question. Feel free, if there's any questions, feel free to ask. Sorry, Ravi, I changed the rules. So what is a digital twin? My favorite definition is shown up on the left-hand side. So digital twin links physical data inputs with a digital model to provide business value. I like the fact that it provides business value. If it doesn't have that part to the definition, a digital twin is then equivalent to the blind man, the elephant analogy. Anything is a digital twin. Anything and everything is a digital twin. So digital twin is something that you create in the digital world, a model that links with the physical system, input from the physical system to deliver some business value. So now you can go back to the 12 cells chart that we had just before this slide, and you can figure out, what type of digital twins would drive business value for each cell in that chart. Other definitions of digital twins: it's a virtual model of a process, product, or service. It refers to a digital replica of physical assets, processes, and systems. And of course, Gartner predicts that half of industrial companies will use digital twins to get 10% increase in effectiveness. So it's going to be used broadly, but it won't be one digital twin. It'll be based on what questions you're trying to answer. Okay, so let's talk about another concept, which is digital threads. It gets confused with digital twins. So let me give you an example. Let's say you design a machine in CAD, computer-aided design model. You create a 3D model of your machine, you design the machine, and now you have a model of your machine in CAD. Then you go and simulate the machine. You build a simulation of how the machine works. So now I have the simulation part. You design the process that the machine runs, you commission the machine, you run it. Now if you bring together the digital model with the physical machine to visualize what goes wrong in the machine. Let's say this machine had that pump we just talked about. Now you can show the pump and show the real-time operating conditions of the pump, right? The pump's running okay, here are the operating characteristics of the pump. That's integrating the digital thread. It's a whole digital thread going from design to simulation to operation. It has an integrated set of digital twins, which when put together, give you some really cool insights. And I'm going to show you a video on how that comes together. So what are business value examples of digital twins? So digital twins deliver a lot of business value. They could be used for training. So when you design a system and you simulate the system, you can train operators on the system. You can use a digital twin for optimizing your design, for simulating the flow, for simulating how products get queued up, what kind of buffers you need to build, and so forth. So analyzing the throughput using a digital twin. You can use a digital twin for software testing. You can write a lot of your control code and run it on your digital twin and verify that the control code is working correctly. You can use it for commissioning. You can use it for operational analytics, like preventive maintenance or line performance optimization. So there's many different uses, and this is obviously not comprehensive. This is just a set of examples of what you might be using digital twins for. So an example of the use of digital twins, and the reason I wanted to include this is a real example that we did for one of our customers. And here you're trying to optimize the performance of a line. And it has two elements to it. It has a simulation of the line, which is an electromechanical system. So it's simulating how the line runs. Another aspect of it is emulation. So why do we need emulation? Because on this machine, there are controllers, like Rockwell controllers. These controllers are running loops at a certain speed. You need to emulate the performance of the controller to really get a good feel for how this line is going to run. So it's a combination of simulation and emulation that come together to create your digital twin and answer the question you're asking here, which is, how do I optimize my line, right? So it's simulation and emulation coming together. So what I'm going to do next is show you a video where we show digital threads coming together with HoloLens, with mixed reality, and how this could all add value. So this was actually done by Microsoft jointly with Rockwell. And one of the people featured in this video is Beth Parkinson. So if you want her autograph, she's here. Okay, now that's not good. I thought this was running. Here we go.
It's like giving someone Superman capabilities.
One topic I'm really personally excited about is the concept of digital twin. We're redefining it here at Hannover Messe Industry.
What we're able to do is actually show this really innovative machine from the Kama Group. It's a packaging machine. It's a physical machine, it's full operation, but we also are able to show it virtually. People talk about this as a digital twin.
It's really like a digital car in real life. We use this in car engineering, mainly in the early phase.
With HoloLens, we can demonstrate that by creating a digital twin, you can really engage with your customers and create unique collaboration scenarios from the design phase into production, into building the process or into the product.
Basically, this gives you X-ray vision. We can project our digital twin inside here, and you're looking at the factory from a holographic point of view.
Issue a Microsoft chocolate.
We're going to command the robot, which is in a chocolate factory, to pick up a piece of chocolate and hand it to you.
We are using this HoloLens in our technical service. On this machine, we have a problem. We are connecting to the specialist that's sitting somewhere in the world.
We've worked with OSI Soft and Deschutes
to do real-time data visualization of the brewing process. We're simulating a problem there, and we're able to do remote assistance to Skype in and look at that problem, resolve it.
Once our clients get in touch with us, they have an urgent need. We create digital twins. So we create a hologram, and this hologram we can show to our clients so they see the future stair lift in their real environment. We are cutting down lead times by 4 times.
This is the largest industry show in the world. It's exciting to see that we have these companies here, both like partners as well as customers, taking the technology of Microsoft and turning it into real business solutions.
Okay, so this example kind of showed how you can pull together data models with mixed reality to create visualization of your entire system. So let's talk about couple of real examples. One is a company that we work with called Metso. Metso is a company that makes machines that crush rocks, for example, in mining applications. These are massive machines, rock crushing machines, for example. So what Metso did is they identified 4 areas that they wanted to focus on. They wanted to reduce the project cost to install these machines, to build and get them commissioned in mines. So reducing project cost was a big deal. Efficiency was another key area for Metso. Energy use. These machines consume tremendous amounts of energy. So they wanted to reduce the energy consumption of their machines, and they wanted to optimize machine performance. So these are the 4 problems that they started out with. So Metso worked with Rockwell and Microsoft, and they implemented an architecture where they're pre-processing a lot of data within the rock crushing machine itself. So they're providing insights to mining customers on how the machines are working in real time. So what the value of doing that is we differentiate between 2 types of analytics: real-time analytics and non-real-time analytics. Real-time analytics are done in the real-time world. So you're processing data in real time as it's being generated and closing the loop in real time. That's the key part. Just doing stream processing of the data is insufficient. That's only half the answer. But using the outcomes of stream processing, of running real-time analytics, to close loops, to actually cause some change in your control system, or to issue an alarm to the local operator. That's a big deal. That's real-time analytics. So they've got that implemented on their machines. They're also collecting selected data and moving it into the cloud. Not every bit. They're pre-formatting the data into structured data. A typical structured data would look like, here is the pressure for rock crushing. This was the state of the machine. Here's a timestamp. It's all put into one data structure. Again, feeding analytics. So they're structuring the data, deciding what data to use. They've created their own data standards. They've created an information architecture. And now this data is moving into Azure Cloud, where they're running another level of analytics, non-real-time analytics. Okay? So that's the key difference. You've got real-time analytics with real-time processing of the data that results in real-time actions, non-real-time analytics that run at a higher level. The digital models that you use are very different. Again, depending on what outcome you're trying to drive, what questions you're trying to answer. So this is one example with Metso that we recently implemented. Another example is one of our customers, a food customer. They had an issue with downtime in the plant that makes coffee beans. And they discovered that most of the downtime was being caused by the dryers. So when you process coffee beans, there are dryers that dry these coffee beans. The heat transfer surfaces get contaminated, and they have to clean those heat transfer surfaces every few hours. So they wanted a system that would analyze how much coffee beans they're processing and tell them when to clean the heat transfer surfaces. Just like your car tells you today when it needs an oil change. Gone are the days of checking 3,000 miles and running into Jiffy Lube, right? We don't do that anymore. The car tells you when it needs an oil change. So here they wanted the system to tell them when the heat transfer surfaces need to be cleaned. So analytics are running in the controller. What we discovered is if you run decaf beans, Decaf beans cause more contamination. I don't know the reason for that. But so by collecting the data on how many pounds of beans are being processed per hour, whether it's decaf or caffeinated, we can now predict, and also the humidity in the factory temperature, we can now predict when they need to clean the heat transfer surfaces. That's increased their uptime significantly. Big deal for them. They're processing the data in the cloud too. Some data is being moved into the cloud. What they're now looking at in the cloud is how are dryers performing across their coffee plants. They have hundreds of coffee plants. So now in the cloud, they're processing data to see what kind of productivity they're getting out of dryers across their multiple plants. You can't do that on premise. You can't do that within the factory. You can only do that in the cloud. Okay. So this is another example of how real-time analytics using real-time digital twins versus non-real-time analytics using a different digital model deliver different business outcomes. So this is what I was going to talk about digital twins. I'm going to switch gears now. I'm going to talk a little bit about another area which is really important for industrial automation, and that's talent. There's a huge shortage of skilled people in the industrial space. As we introduce digital twins, as we introduce more complexity with IT/OT integration, talent is going to be a major, major issue for industrial manufacturing. So I just wanted to share with you a very innovative program that Rockwell came up with jointly with Manpower. We decided that we're going to retrain veterans. Every year, roughly 200,000 people come off of the military. And these 200,000 people, many of them, majority of them, don't have a good job. What if we retrain some of them to work in manufacturing? Because a lot of these veterans are proficient with electromechanical systems, electronic systems. You know, they handle pretty complex systems. These are smart guys and gals. So we started a program last year in August, and I wanted to share with you a video of the Academy for Advanced Manufacturing, which Rockwell kicked off. We have big ambitions for it. Right now, we're training a small number. We want to get up to 2,000 a year. Right now, we're training, the most recent class has about 24 people in it. But I want to share a video with you that shows how transformative these type of programs can be.
The interesting part about this program, the Academy of Advanced Manufacturing, is it separates itself because it's number one, it's filling a void in the manufacturing world. We're filling a skills gap. But the other part of it is we're employing men and women who sacrificed for the country.
My name is Christopher. I was in the Army, and I was a 14 Tango, which is a Patriot Air Defense Artillery.
My name is Jin. I was a communication, navigation, and mission systems technician for the Air Force.
I'm Chad. I was in the United States Marine Corps for 7 years. Had some medical issues and ended up actually being medically retired. When I first got out, I was looking at the job boards and I actually saw, a lot of jobs out there for automation and manufacturing, electrical, electronics type stuff. And I'm like, oh, okay. I've got the electronics experience, but I don't know anything about PLCs or HMIs or any of this stuff at all.
It took a toll on me emotionally because I went from this guy who's traveled the world. I felt like I was worth nothing to anybody because, I started looking for jobs. I really couldn't get any jobs or anything, and people were confused as to what I wanted from my resume. I had to start from scratch. I got contacted and did a phone interview. They were really excited. I was really excited. And I said, hey, you know what? This program seems like it was made just for me. Not only for veterans, but it's in the industry, the manufacturing industry with the controls and automation, which is something I've always wanted to do, but I was never able to get into it.
Definitely, I'm nervous, but I'm excited. I mean, as to which most people would be. I mean, I come from a background of doing a lot of hands-on things, troubleshooting, doing technical, solving technical problems and such. So it's exciting to get to come in.
As we embark on this program, the great thing about the partnership between Rockwell Automation and Manpower Group is we each bring elements that are critical to make these 15 people that are on pilot successful. And for them, success will be measured by proving out what they know via the Applied Learning Project, doing well on their engagements with their future employers, getting job offers, and having the opportunity of moving into a new role.
So one of the reasons I wanted to share this video with you is we need innovation in training. This type of training requires a lot of equipment because there's a lot of hands-on training involved. We have labs set up where these veterans go in and program PLCs, they troubleshoot PLCs, they interact with PLCs. So we're looking for innovation from Silicon Valley to make this easier, to get training to another level where when you have systems training and hands-on training, how could you scale? This is difficult to scale because it requires a lot of lab work. So what are some breakthroughs that we can come up with to create something that could be scaled more significantly? Because this is going to be a huge issue for our country. We will need more qualified people. That's why I wanted to share this with you. So just to wrap up, so with manufacturing, the vision that manufacturing is going to be a lights out factory, no people, that's yesterday's vision. What is coming out today is manufacturing is going to be more self-adaptive and self-healing. It's a key element of the enterprise. It's going to be connected to your customer demand. It's going to be connected to your supply chain. It'll flex based on what your customers are asking you to do, what's being consumed in real time in the marketplace. So like, for example, a lot of our customers make packaged gifts in November, December timeframe. You'll see them at Walgreens, you'll see them at stores. People buy them as Christmas gifts. Which packaged gifts are selling the most? If you knew in real time which ones are the most popular, those are the ones you produce, because a lot of these get returned. A lot of these get returned. So how do you minimize those losses? How do you minimize the returns? You know what's most popular today? You make those the most. Change instantly. So manufacturing is becoming a part of your enterprise nervous system. It's going to be driven by your customer demand. It's going to be driven by the supply chain. It'll be highly optimized, self-healing, and self-adaptive with a lot of application domain knowledge that drives analytics, that drives uptime, that delivers the business outcomes we talked about. So that's the difference in the vision from what it used to be in the past, which is essentially an isolated plant with barbed wire fencing in the outskirts with no people. And there are such plants today. I saw one in Japan where robots are making robots. So that vision is changing, okay? So that's kind of the end of what I wanted to talk about. Now I'm going to turn the tables over to you. You get to challenge and ask questions. So first, I really appreciate the time this evening, and hopefully I deliver on giving you one or two insights that you didn't have. So let's turn it over for Q&A.
We have a second mic also, Civil.
So thank you. So you did say that you want to get some controversy out there. So you did say structured data. I agree with that. You said no big data. So why not big data? Why not a lot of data? I mean, what is the definition of big data and how you actually get all these insights without sufficient data?
Great question. So I qualified that by by quietly saying that for non-stochastic systems, you don't need big data. So systems that you design a machine, you built that machine, you understand how that machine works. I don't need to collect every bit of that data, every bit from that machine to come up with some insights that I didn't have. You know how that machine works. If the question you're asking is, I want to make sure this machine doesn't fail much, what data do you need to determine that? What are the weakest points in the machine? You collect that data. So for those types of systems, you don't need big data. Today, we don't even think that way. But for stochastic systems, like for example, you have oil wells, you're pumping oil out of reservoirs. You have to optimize how much oil you pump from a reservoir using complex models. We don't really understand that whole process. For that, go at it. You need big data because we don't understand the correlations. But for processes, for systems where you have non-stochastic systems, you need more structured data, not big data.
We have a question right here.
I had a question which is slightly adjacent to your topic of presentation. There's a whole ecosystem of startups that have come up, Silicon Valley and many, many other places, Bangalore. Many VCs and angel investors investing in these startups that are focusing on AI applications. But many of them are also targeting industrial use cases. And what advice would you give those startups as a way to get in and open the doors on some of these industrial use cases, specifically with a view to solve some real problems, deliver real value? Many of these folks come up from a traditional software development, right, AI type backgrounds. They don't necessarily have a very deep domain experience, say chemical engineering or mechanical engineering. They're more software engineering, computer science. What kind of advice would you give them as a way to break in and be able to solve problems that are more on the OT side?
So today there is no shortage of companies that are promoting analytics or developing analytics. There are virtually hundreds of startups that are working on ML and AI-based analytics. The advice I would give them if they want to go in the industrial space is to focus by industry vertical. For example, focus on problems in the industrial space, focus by specific areas. For example, there's a company that does just diagnostics for oil wells. That's all they do. They understand how oil wells work really well. They've tailored the analytics to correspond to electrical submersible pumps that run oil wells. That's of value. Oil and gas companies will invest in that. They'll buy that solution. But if you say, I've got the best analytics software package, it's better than Watson, come buy this, that's not the right approach.
So there's a lot of companies that are calling themselves platform plays, even though they have elements of machine learning and stuff built in. In the long or medium or long term, how viable do you think platform plays are in a domain specialist space such as oil and gas?
Yeah, so those platforms have to match the domain. So if the platform has machine learning built in that matches the problem set in oil and gas, it'll get adopted. But you got to demonstrate that. Without that demonstration, without some real value coming from that platform, it'll remain a platform. Because there are many, many, many different platforms. And companies are looking at them, but they don't have time to evaluate every platform.
Hi, Sujit.
Yeah.
So the question is about edge computing, and I'm just wondering what's your view on edge computing per se, because a lot of field service and manufacturing customers today talk about edge computing because low energy, small data at the edge, and so that's one. And the other question is there are a lot of IoT platforms coming up, especially by OEMs. Hitachi, GE, Siemens, everybody's building its IoT platform. What is the future like? The multiple IoT platforms running around, connecting to each machine, talking to multiple IoT platforms, that kind of thing. So one question on edge computing. What's your view? And the other one on this.
So let's address edge computing first. in the industrial space and maybe outside of the industrial space, machine builders understand the machines best, right? So if you design a machine like Metso, they understand their rock crushing machine the best. Their engineers know how the rock crushing machine works. So their engineers have the insights to correlate the right types of data. We're not talking about relating cupcakes consumed to computer science graduates. You're talking more about what data drives business outcomes. And those engineers who design the machine have that insight. They're the ones who are going to start implementing the lowest level analytics. They're going to be analytics that will be done at a higher level, like comparing performance of multiple machines across different sites. That'll be the cloud. So edge computing, you already have a compute surface at the edge, which is significant. You have enough compute power to do some lower level processing at the edge. You can't do everything at the edge. You can't run ANSYS finite element models in a controller. It's just not feasible. That's not going to happen in the next 3 to 5 years. Depending again on the business outcome, a lot of analytics are getting embedded by companies like Metso, companies that are designing these machines in the machines themselves. That's going to cause an increase in the amount of edge processing that's going to be done. Not the great news for cloud providers, but that's the way things are moving. That's a direction. That's a vector. So edge processing is on the increase. Companies are realizing that they do need to go in that direction. Yes?
Liz, I was going to say that I agree with your controversial statement. We actually develop computer vision systems for the paper vertical and metals production. So for example, we put computer vision cameras, anywhere from 2 to 45 cameras up a paper line. And we know exactly where to put them because people know what could be a potential root cause of a web break.
Correct.
And by the way, a web break costs $30,000 every time it happens.
Yeah, I'm very familiar with that.
Similar to edge computing, SMS or voice machine builders, they know machines best. They know what could be the points of failure. So they're already pushing the computing there as well. So if anybody wants to know that, that's what we do. But I'm curious is, how fast do you think these machine builders will be moving towards some of the frameworks that you're talking around digital twins?
And they're moving quickly. So take a company like Barry Wehmiller. They are in the same or similar space that you talked about. They're a St. Louis-based company that makes a lot of machines for paper handling. And what Barry Wehmiller is doing is they put in lines at customer sites. A line may have 30 controllers on it. So they're pre-processing a lot of the data in an edge computer and delivering edge analytics, real-time outcomes, and then they're deciding what data to move up into the cloud. So they're already moving in that direction. And they're trying to use as many commercially available platforms as they can. On the edge side, luckily, they're using Rockwell Automation. We're very happy with that. But on the cloud side, they're using Microsoft Azure.
Sujit, thank you for a great presentation. I'm Ravi Chalaka. I'm going back to your provocative statement. You made something to the statement that unstructured data is not going to be, it's all going to be structured data going
Not
forward.
all, but stochastic, not
Well,
stochastic.
even then, in my opinion, that data is not just coming from machines based on our private. In fact, we looked at 4 M's: machines, man, the operator, that is, of a truck or the machine, the materials, and methods. And only if you get all of that different data, you can run efficiently, make decisions on the machine, get the best outcome. So there's a lot of unstructured data, in fact, more so than structured data, that you will have to evaluate. Like a operator saying, I heard a sound, and he leaves a voicemail, and that's part of the data that you have to do NLPs to be able to validate what that meant as a source of information. So there's going to be videos, pictures, images, voice, all should be accounted for, not to mention social media and other value.
Right. So let's talk about that a little bit. So let's talk about the vision systems that she just spoke about. So vision systems are collecting information on how a line is moving. You have video imagery, you may have pictures. I can collect every video image that I have and dump it into the cloud. But if I take that video and link it to a fault condition, and create a structured data type that says, when this fault occurred, here's the video segment. That is a lot more value than just dumping the entire video segment up in the cloud and trying to correlate it to what goes on. Then you need the data janitors. So the point is, yes, you have many, many sources of data, not just machines. You've got vision systems, you've got people, but to the extent that you can link that data and create structured data types based on the outcome you want to drive, sure, there's going to be some data you just can't pull together. Fine, then you just pump the data up and link it at a higher level. But it's case by case. If I were to say a number, I would say 80% of the data is going to get structured at the edge in the manufacturing space.
You mentioned that an industrial IoT engagement shouldn't just be throwing a team of data scientists at petabytes of data and then computing something that isn't actionable, like the correlation with the consumption of cupcakes. But so what's missing? What's broken? What needs to change so that engagements are more actionable in your opinion?
Excellent question. So what's missing is data standards, interoperability standards, orchestration, data orchestration methods that really work well. Complexity is very high today. You're dealing with enormous amounts of data. I mean, petabytes. So how do you orchestrate the data? How do you create data structures? How do you drive standards? How do you manage information in layers? Because your information is getting built up. Your data model starts at the device level. It gets a little bit more complicated at the machine level. It gets more embellished at the line level, further embellished at the plant level. So you're kind of building up the data models as you go up in the hierarchy, right? So how do you manage that data? How do you create standards to work with that data? How do you match analytics to the business outcomes? We talked about many analytics platforms that are available today. What's best for the problem you're trying to solve? So a lot of people in our industry are confused. We haven't seen the knee point yet for growth. Everyone is kind of the flat curve right now. Everyone's interested in digitization. Everyone's talking about analytics, but no one's really writing the checks yet. So there's that knee point that we're going to hit, and it's going to happen soon. But there are some breakthroughs that are needed.
I mean, who do you see driving a push for standards?
I'm sorry?
Which organization or which company do you see actually leading a push towards open standard?
So every industry vertical is driving open standards. Oil and gas is working on open standards. Industry 4.0 is working on open standards. So, but standards, as you know, don't move at Silicon Valley speed.
So,
5 years would be the minimum. That's if you're lucky. And everybody agrees because these are international standards.
So great talk, Sujit. And I agree with your view that like machines are like non-stochastic. So I mean, we do not need big data for some of the scenarios. But what about like issues where there is an installation issue with the machine or there is an issue with the raw materials and you are having some failures and which are not like based upon some law because those faults were never taken into consideration when you were using the physics formulas for the breakage, or even like in the cases where you have a component failure and then you're trying to predict which component is going to fail the next, and that can vary from plant to plant, from machine to machine, from installations to installations.
Yeah, so there are going to be cases where you have non-stochastic behavior where you do need to collect data.
We have dealt with these scenarios.
There will be scenarios like that, so completely agree with you. But hopefully that's not the majority of scenarios.
My question would be, the IT-OT convergence seems to be driving a lot of OT companies to believe that they need to become software companies. Do you think that's right, or shouldn't they become data companies? I ask because we are a software IoT company.
So John Chambers said that every company is going to become a software company. Domino's, I was talking to the CTO of Domino's. He told me that Domino's is a software company. I said, geez, you guys make pizzas. You can't be a software company. But he said, look, all of our investment is in software. I mean, if you go to a Domino's site and order a pizza today, you can track how quickly that pizza is being made, what's being done. The experience on a mobile device is really, really good. It tells you exactly when that pizza is going to be ready. So you're there on the dot to pick it up. That's what they're investing in. That's what they're working on. They're not trying to improve the pizza. So a lot of companies are becoming software companies, and they're also data companies, to your point, because they're optimizing a lot of what they do with the data they're collecting. So you can't do one without the other. You're becoming a software company, and you're driving what you're doing with a lot of data you're collecting.
Yeah. So my question is back to your digital twin. And so if you think about the physical world, so physical world had a history, right? And also the current status, and also the future. And so future is you have probably the planning and the possibilities all there. And according to, I just want to understand from your perspective, and what is the digital twin you talk about here? And so is it combined together, or just a special snapshot, or what is your definition?
So back to the definition of a digital twin. There is no a digital twin. A digital twin is a digital model that delivers the business outcome and answers the questions you're asking. And in that chart that we reviewed, where we had the 12 cells, different questions, different digital models. So if you call the digital model a digital twin, it has to be adapted to the questions that you want answered. You're not going to have one digital twin that answers every question. It's pretty evident when you look at that chart. So there is no one digital twin. There are digital threads. Digital threads will integrate digital twins to give you better visualization, to give you better insights. So we got to differentiate between digital threads and digital twins. That's why this whole area is so confusing, you know, blind man and elephant.
Hi, Sujit. Thanks a lot. This was a very, very awesome presentation and brought a lot of clarity and structure into the whole AI and enterprise, as well as generally around IoT. So my question actually goes back to the earlier point that one of the gentlemen made there around platforms. So again, going back to the Silicon Valley model, right? You kind of build these software systems and focus more on the software and the analytics. And then they look for some vertical to go after. And then they end up customizing for that vertical. My hypothesis is that as you kind of build a platform and customize it for healthcare, let's say it's IoT security, you try to apply that same model, it might not work without a lot of customization. Say in manufacturing, you take the conceptual piece might be the same, but it might not work for oil and gas. So what's your thought process and what's your advice?
Yeah, so you want the platform to be horizontal. Essentially, it's the same platform, whether it's healthcare or manufacturing. But depending on how difficult is it to apply, people are going to use it. If it's really easy to apply in manufacturing, you've got a library of modules that drive your platform, and you can demonstrate value of the platform, then the adoption goes up. So if you have a horizontal platform and you want to go after multiple industry verticals, you got to build a stack on top of that platform for each industry vertical to demonstrate value. Otherwise, there's so many platforms out there. It's just very confusing.
Thank you very much for the talk. How do you avoid vendor lock-in in digital twin? At the end of the day, you said digital twin has to provide business value. And if there is no standardization on edge fabric, how do you assure you're not getting locked in?
So very insightful question. This is going to progress in phases. Initial phase, you cannot do without vendor lock-in. You have to have some vendor lock-in. But as you progress, as more open standards become available in about 500 years, it'll open up. So you're going to have multiple vendors building to the data. So as standards evolve, until standards become prevalent and adopted, you're going to have some vendor lock-in. There's no other way.
All right, thank you for your talk. In reference to your
this is really loud. In reference to your vision of digital twins, I think it's similar to your question. It seems today that a digital twin can be a very valuable thing, but it seems bespoke, handcrafted, use case by use case. I think that's true. I'm not sure. I was going to ask you first, are they bespoke today, or does Rockwell have a platform for creating them by case? And really my question is, this is Silicon Valley. So what role do you think Silicon Valley can play in the future of digital twins?
So, good question. The digital twins have to be in a library to start out with. There's some customization that's going to be needed based on how you configure a machine, how you configure a system, but that's configuration, not reprogramming the digital twin. So if you create a library of digital twins by industry vertical, and you are able to classify and drag and drop them, create an open source library of digital twins. So every student, every professor creates digital twins for life sciences, for example, for pharmaceuticals. And they put it up in an open source site. People can grab and customize those for what they need. That's going to create that knee curve for adoption of digital twins. We don't have that yet. So we need to create the infrastructure to have a lot of people creating digital twins and putting them up on a site where people can grab and use. So you can't create bespoke digital twins, because then there's no scale. But if you create digital twins that can be customized, a base set of digital twins for an application, grab those, customize them, they are now bespoke for your machine. That's the breakthrough we will need.
Last couple of questions before the raffle. What? Gotta stick around for the raffle.
So Sujit, very nice talk. You mentioned that people are not writing big checks yet. So based on your conversations with companies, what needs to happen for them to write those checks, and when do you think that'll happen? Is it next year, 2 years? What's your prediction?
I wish I knew. I don't know. But again, it's all going to come down to how quickly can you demonstrate business value. Because if I go to my CFO and say, hey, I need a big check to write to Microsoft so I can buy Cortana Analytics, I can buy Azure, install it, I'm going to build this infrastructure to move data from Rockwell's 28 factories into Azure. He's going to say, well, that's all cool, but what are you going to do with it? How will I justify a business case for the $10 million investment you're asking me for? If you can answer that question, if you can show the CFO that, hey, by putting in this infrastructure, by putting in these analytics, you're going to increase your uptime by 40%. That's going to increase your revenue by 10%. That's going to increase your operating earnings by another 10%. Yeah, the CFO says, where do I sign? We are not there yet.
Any other questions? All right, one in the front.
A typical use case that I've seen is that, let's say I'm putting up let's say food and beverage company. They're putting up bottling machines. They're putting up, let's say, conveyor belts and stuff like that. And the OEMs work on different IoT platforms. So let's say bottling, I have specific use case here. So bottling machine manufacturer works on, let's say, a Siemens IoT platform, conveyors on something else. But I'm a beverage manufacturer. So this goes back to a question that I just raised, that there are multiple IoT platforms. So what is the future like as a, and I want to go to Rockwell, for example, as a beverage.
So in the example I gave, Barry Waymiller, they use multiple platforms. They use Siemens, they use Beckhoff, they use Rockwell, they use multiple platforms. So what we've done for them is there's a gateway that collects the data and organizes the data. So they're all producing data. They're different platforms, but they're all producing data. If you can collect the data based on, again, the business outcomes, create the right models, structured data for them, that's really what they want. So there are gateways available today that'll collect data from any IoT platform out there. And that's the point where you start consolidating the data.
Great. With that, please join me in thanking Sujit Chand for an excellent talk.